In this question, it says in the following figure, showing a germinating gram seed, name the parts labeled A, B, and C. So what you can see, I've taken a picture from the textbook as well. You can see that this is cotyledons, that is over here, portion which is I'm shedding it. The cotyledons are these, right? This is actually it stores food, right? This portion it stored for food for the germinating. So these are cotyledons. Well, this is dicot, right? Having two cotyledons, that's why I'm saying it's dicot. Now, next is leveling A. As you can see that this is A over here. A is what? Plumule, which is nothing but the future seed here. And if you see the B, sorry, C from here, not B, C from here is what? The radical, which is the future root. So one more time, the B, which is yellow painted over here, which I shaded yellow, is cotyledons, which actually store food here, right? You should know that it store food. And next is A I was talking about. Next is what is A? A is plumule. That is for the future shoot that will grow into shoot later. And this being the future root, that's known as radical. Right. That's how we'll answer this. The question here is that blood circulation in the fishes is different from the blood circulation in human being, and we have to justify this. Well, I've taken this page from your textbook NCRT. As you can see that it's written that fishes, on the other hand, only two chambers heart, unlike in human being, which has four chambered heart, and the blood is pumped to the gills. So the oxygenated blood, right, thereby passes through the rest of the body. So what you can understand that in case of human being, there is a four-chambered heart and double circulation takes place. So you can figure out from this what I can see in this diagram, that first the blood enters the heart into the left atrium. Through left atrium, it goes to the left ventricle. From left ventricle, it goes to the rest of the body, and then from the rest of the body back to the heart. It does not go back to the lungs. It enters again it to the heart, that is on the right hand side, which is right atrium, then to the right ventricle, and then back to the lungs. So over here you can figure out that the blood enters the heart twice. Let me one more time, I should show you, it is important that yeah, that's the circulation of blood. So you can see from here, the first the blood enters into this left atrium, then it goes to the left ventricle. From left ventricle, it goes to the rest of the body. And once it is oxygen blood is used up, the blood again comes back to the heart, this time on the right hand side, that is on the right atrium. From right atrium, it goes to the right ventricle, and from right ventricle, it goes to the lungs for the reoxygenation over here. So you can clearly see that the blood enters the heart twice in human being. But this is not true in case of fishes. They have a single chamber, single circulation, right? So this is what you have to remember and describe the circulation of blood in the human. So I think I have answered both of it. So for circulation of blood, you just have to remember the flow of the blood into the heart, that is from lungs to left atrium, from lungs to left atrium, from left atrium, lungs to left atrium to left ventricle to the rest of the body back to the right atrium to right ventricle back to the lungs. Then you also should mention the pathways, that is the it enters the heart through pulmonary veins, goes to the rest of the body through the largest artery called aorta, and come back to the heart, deoxygenated blood from the largest vein called vena cava, and goes back to the heart, lungs using pulmonary artery. In this question, it says, give the constituent. We have to find the constituent of baking powder. Well, its answer is there in the book. You see, for making baking powder, what we need, it is basically a mixture of sodium hydrogen carbonate, that is NaHCO3, and a mild acid, right? Mild edible acid, such as tartaric acid. Since the formula of tartaric acid is quite complex, for class 10th, we just use H plus, indicating that we have added tartaric acid here. And what you can observe that during this reaction, when it is heated, we get carbon dioxide, water, and the salt of that acid. But this carbon dioxide is most important here because the carbon dioxide so produce the reaction that causes the bread to rise. Let me show you what actually happens. Let's say if I take a dough over here, I'm taking a dough. Let's say I took some dough over here and mixed with baking soda. So what happens when it is heated? When this is heated, dough is heated, what happens? There's a tiny holes comes into it, and this holes comes because of when it is heated, the dough rises as the carbon dioxide coming out of it, making small pores. As you can see, most of the breads you eat have these tiny pores because the carbon dioxide escapes out of it, making a dough. Now, if I read the later part of the question, it says, why does the cake or the bread swell? We know the reason, and we have to write down the chemical reaction in this case. So remember, as I said, we don't have to write down the actual molecule formula of tartaric acid. Simply write baking soda, that is NaHCO3 plus H plus. On heating, it will give carbon dioxide, water, and the salt of the acid. The question which is asked from this topic is describe an activity to show that chlorophyll is essential for photosynthesis. So these are the steps which you'll be writing. So first, what thing that you'll do is to take a potted plant, right, and keep it in dark for 3 days. Now we keep the plant in dark for 3 days for the reason so that it get de-starched. So what we want that the starch which is already present in the plant, as you know, plant make food which is actually in the form of glucose, but they store it for the future in the form of starch. Now we'll be taking a leaf of what we should say that variegated leaf. That means they should have chlorophyll in patches, not throughout. That is croton and or money plant. You can take any of them. Now we keep the plant in the sunlight so that freshly prepared starch comes to this. Then what do we do? After that, we mark the area. So what you can do is you can take a tracing paper over here. Let's say I can show you what I mean to say. Let's say I took a tracing paper over here and I'm marking the areas which are those areas where there are chlorophyll. Right. You can see mm, I'll be marking like this, right? So you can just be drawing its border, could be like this over the tracing paper, right? Okay, and then you remove this tracing paper. Let's say I remove this paper from here, keeping it aside over here. Now, after that, the next thing that you'll do is to boil this leaf here. Now, why do we boil it? So that the cell become dead and the cell wall becomes soft and easier diffusion of iodine can takes place. After that, what you'll do, you'll give a water bath. Now, what is water bath? You know, we have to boil this in an alcohol, but you know that alcohol is highly inflammable. We cannot boil them directly. So we'll be boiling this, but keeping it in a big, what you said, should say, in a boiling tube and putting it in a container with water, right? So we'll be boiling them inside water, right? As you can see, not directly, right? So what happens that with times you will find that this chlorophyll which is present over here dissolves on the liquid, and slowly you will see that all chlorophyll will come into this water, will get dissolved into the water, and this will look a bit colorless. The leaf will become colorless. Now after taking out from here, you can do one thing. You can remove this. You can boil this, not remove it, boil it in running water to remove the alcohol. And then you are going to place, put iodine solutions into it. As you know that iodine is used to test the presence of starch. And then when you replace that, this one, right? One second, the tracing paper over here. So when you put this back, you will find that chlorophyll, those portions which were marked will turn blue black and the other portion does not. So it shows that starch is like chlorophyll is necessary for the photosynthesis. We have one case-based question based on refraction. The question says, note a young student was trying to demonstrate some properties of light in her class in science project. She kept box She kept X inside. So inside this box, there is an optical device, can be a mirror, lens, or any other. With the help of with the help of laser, made light rays pass through the holes. So there is a hole over here. There is a hole over here, and through which the rays of light is entering and it is coming out. The emergent rays are this only. Right. She had made a small butter paper screen to see the spot of the light being cast. They have emerged. So what she has done, that she has placed a butter paper on these portions so that to see the emergent ray. Now check what we have to find write as the question. So what is the first question here? Is this? Okay, I've taken two questions inside. What could be the X that she has placed inside the box? So what you can figure out. First thing is clear that the ray is emerging out from here. The ray is incident and it is emerging out from here. Clearly, it cannot be a mirror because the mirror would have reflect back the rays in this direction. Cannot be mirror. Now, if I check for the convex lens, if I ask you, can it be a convex lens, then you would say that convex lens will converge the rays of light. So the rays of light coming out should have met, right? Con, convex lens is converging lens. Now, if I ask you, can there be a concave lens? Then your answer would have been no, reason being, in case of convex lens, the rays would, that's a diverging lens, right? So the rays would have got diverged. Now check what you can figure out from here, that here the rays are neither converging nor diverging, instead getting laterally shifted. You see, the undeviated rays would have gone in this direction, but it is laterally shifted, implies that the X has to be a glass slab. Okay, now the next question is also a ray of light facing normally, what are the values of the angle of incidence and angle of refraction? A rays of light falls normally. Normally means what? Which is placed perpendicular. Let's say if I make a glass slab over here, and if a ray is falling on this along the normal is very clear to understand. This is along the normal, goes undeviated. No deviation takes place. So here we say that the angle of incidence as well as angle of refraction is 0. Now let me come up with the next question. What are the next question? Over here the same thing is coming. So let me take out the other one. Just a second. Where is that gone? Okay. So the third question that I have to take was this. Yeah, the third is this. So let me raise the previous one. The third question is this. It says she measured the angle of incidence on both rays on the left hand side of the box and is found to be this, and she knew that the refractive index of the material inside X, which is glass slab, is 1.5. What will be the approximate value of angle of refraction? So what you need to remember here, that is the laws of refraction, which says that refractive index, Ri, so Ri can use, or say Ri is what? It is sine of angle of incidence to sine of angle of refraction. What is refraction? Refractive index given is 1.5. So let's replace it. What we know, the angle of incidence. Let me check again. She measured the angle of incidence, right? And is found to be how much? Sine, the angle of incidence, right? I is given as 48.6 degree. So it should be what? I'm going to replace this I with 48.6 degree, that divided by sine R. So now we have to get the value of sine R. In fact, we have to get the angle of refraction. So now if I shuffle or do cross multiplication, I can say sine R is what? Sine. Achha, one more thing. This value of this is given to you, right? The value of this, as you can see, the sine 48.6 is this. There is a printing error. The degrees over here. The decimal is over here. So I can replace the value, right? As you can see, I can replace this with 0.7, 0.75. Right. So what I'm doing, I'm doing cross multiplication. So 1.50 I can write here, which is nothing but half. So we got sine R is equal to half. And for what value of sine is half? It's sine 30, right? Sine 30 degree is equal to half. So from here we can say that R is how much? R is 30 degree. I think you can figure out, right? That's not a difficult thing. If you have done trigonometry, it's very easy to do. There was one more question. Let me take out the last one. So the last question is what? I will take the last question. Yeah, the fourth one is here now. Let's check for the fourth one. What does it say is that in an experiment, the student observed the angle of incident at 55 degree within normal, okay, on one face of X after refraction strikes the opposite face of X before emerging out in the air, making an angle of 40 degree with the normal. So we have to draw a level diagram showing the path. Okay, so the diagram is what we have. So let's say if I make a glass slab over here, this is a glass slab I made here. First, I'll make the normal at the point of incidence and the angle of incidence. So the incident ray is making an angle of 45 degrees. So this is I, which is not 45, it's 55 degree as for the question. So as you can see that the rays of light, if goes undeviated, would have gone in this path, but it will bend towards normal. As you know, the rays of light going from optically rarer to optically denser medium bends towards normal. So I'll make this as the another normal at the point of refraction. And finally, the emergent ray here, the emergent ray would actually go on away from normal. Well, anyway, we just need to describe these angles. So let's say this is OAB as the incident, BC as the refracted, and CD as the emergent ray. And making these angles, say this is R2, no, this is R1, this is R2. What I'm doing is I2 angle of second angle of incidence. So this is I2 and this is, you may write E for emergent ray. That's how we'll do this question.